I'm Lois Letchford, author of the book Reverse to Memoir, literacy problem solver, and co-founder of Teaching Students with Dyslexia Reading and Writing program. And I'm reading about people who changed the world from the book Eureka. And today I'm reading about a woman, Cecelia Payne Gaposchnokkin. She was born in 1900 and died in 1979. I hope I pronounced her name correctly. And she's the US astronomer who told us the makings or the makeup of the universe. In 1835, the French philosopher Auguste Comte declared we would never know the chemical composition of the stars. He added, I regard any notion concerning the true mean temperature of the various stars as forever denied to us. When you make statements like that, you know you're going to be proved wrong. It's one of the great failed predictions of science history. Within the next 2 or 3 decades, the new science of spectroscopy so much improved our understanding of the stars that by 1861, the UK astronomer Warren de la Rue claimed, if we were to go to the sun and bring back some portion of it and analyse them in our laboratories, we could not examine them more accurately than we can by this new mode of spectrum analysis. In 1802, long before Comte made his doom pronouncement, the UK chemist William Wollaston noticed that the spectrum of the sun's light contained not just the spectral colours but also some narrow darker lines, and in 1814 the German optical scientist, working much more precisely, discovered that there were hundreds of these. The big breakthrough came in 1859 when they showed these lines were caused by absorption of some of the sun's light by chemical elements present in the cooler regions above the sun's visible surface. Every element produces and absorbs its own spectrum of light, and the study of the lines in the solar spectrum could be used a little like a fingerprint to determine the elements present there. It's very fiddly work, even for a star as close as the sun. How much trickier it would be if you're working with a spectra of distant stars whose light is many millions of times fainter. So Cecelia was born in Buckingham in England, and she studied botany, physics and chemistry at Cambridge. And while there, she attended a lecture by the astrophysicist by Arthur Eddington that sparked her interest in astronomy. Although she did well in her examinations, she wasn't awarded a degree, mainly because she was a woman. Thus, she decided to move to the US and to the Harvard College of Observatory in Cambridge, Massachusetts. Here she did pioneering work on the classifying the spectra of the stars. Her PhD thesis was able to show why the stars were in those different spectral types. Early astronomers had thought that the strength of the element's fingerprint in the star's spectrum included or indicated how much of the element was present there. She correctly reduced that. Instead, the lines indicated the temperatures of the stars. Different elements ionized to different degrees at different temperatures. The strength of the fingerprint depends on how much the various elements had ionized. This piece of work has been described by various astronomers as perhaps the most brilliant thesis ever written. One of those who agreed was Payne's supervisor. However, he disagreed with the conclusion that stars were made up of almost entirely of hydrogen plus a small amount of the lightest element, helium, and with other elements present only in traces. At the time, astronomers assumed the elements were present in the same proportion in stars as here on Earth. So Russell advised her to suppress or downplay her conclusions because he was one of the most prominent astronomers in the world and she was a mere postgraduate student. She immediately added a comment stating that the inferences were almost certainly not real. In other words, that her results were real enough, but her interpretation of them was likely faulty. A few years later, in 1929, Russell changed his mind and published a paper concluding that the stars were, and the universe was, made up almost entirely of hydrogen. So that's, her greatest contribution was the discovery that almost all of the matter in the universe is hydrogen. So find out more, read more, enjoy, find out about people who made contributions to our world with phenomenal impacts. Thank you. Hit like, hit subscribe, and share it with others.